Hey everyone, today we will be graphing quadratic equations in standard form, so let's get into it. Recall that the standard form of a quadratic is f of x is equal to ax squared plus bx plus c. And remember that the a, the b, and the c's, so a, b, and c, are just numbers. So we talked about these key characteristics of a parabola, and now we're going to figure out how can I find those algebraically. Well, the axis of symmetry, they're all going to involve these a, b, and c's. So the axis of symmetry is that vertical line through the vertex okay? And the equation for that, remember a vertical line is always x equals. And how can I use a, b, and c? Well, the equation of the axis of symmetry is x equals negative b over 2a. So that's the equation to find the axis of symmetry, or the AOS. For the vertex, remember that your vertex, the x-coordinate is your axis of symmetry, because the AOS has to go through your vertex. So the x-coordinate is always going to be negative b over 2a. And then to figure out what the y-coordinate is, you're going to plug negative b over 2a into your function. So I know that this ordered pair looks confusing, but the x-coordinate is always going to be your axis of symmetry, and your y-coordinate is always going to be the number that happens after you plug your AOS, plug your axis of symmetry into your function. Okay? So that might take a little bit of work, but we'll get through it in a little bit. Our y-intercept, remember our y-intercept is what happens when my x is 0, and then I plug 0 into my function to see what I'm going to get. But notice, if I plug 0 in for x, both of these terms are going to cancel out, leaving me just with the c value. So my y-intercept is always going to be 0, comma c. And then last but not least, we got x-intercepts. And these are going to be a little tricky for right now. We're going to wait till graphing. So we're not going to find our x-intercepts unless if we graph it. And then we're going to approximate if they're not nice values, or we're going to label them if they're nice whole values. And you'll see what that means in a little bit. All right, so those are our main four for right now. We're also going to talk about concave up and concave down. How can I tell whether or not my graph is going to be opening up or opening down? Remember, concave up, your parabola is going to look like this. Your vertex right there is going to be a minimum. So how do I know whether my parabola is going to open up and my vertex is going to be a minimum? Well, the a value has to be bigger than 0. So a is positive. If your a value on your standard form quadratic is positive, then you're going to open up. So conversely, on the opposite side, if I'm opening down and my vertex right there is a maximum, then my a value has to be less than 0, or my a is negative. So, just by looking at the a value, I'm going to be able to determine whether it opens up or down, and whether my vertex is a minimum or a maximum. So, let's get into an example. Identify the key characteristics of this quadratic. So what I want to do with these problems is I always want to list what is my a value, what is my b value, and what is my c value. So once we've got the a, b, and c, let's go into this. Let's find our axis of symmetry. Our axis of symmetry is going to be x equals negative b, so negative 4, over 2 times a. So 2 times negative 2. And if I simplify this, negative 4 is positive 4. 2 times negative 2 is negative 4. If I simplify that, my axis of symmetry is x equals negative 1. So now what I want to do is I want to find my vertex. So I already know that the first coordinate, the x-coordinate, is going to be my axis of symmetry. To figure out the y-coordinate, I need to plug -1 into my function. So my function is here. So f of -1, I'm going to take -2 times -1 squared minus 4 times -1. Running out of room here. Let's see if I can make it work. Plus 6. I can't, so I got to take 2. So I've got -2 times -1 squared minus 4 times -1 plus 6. Made it fit there. All right, so when I simplify this, that's going to be -2 times +1. -4 times -1 is +4. Then I got plus 6. So I got -2 plus 4 plus 6, which is going to give me a value of 8. So f of -1 was 8. So my vertex is going to be -1, 8. My x-intercept, I'm not graphing it. I'm just getting the key characteristics. So wait until we graph. So don't worry about that for right now. For the y-intercept, we're just looking at the c value. So I plug in 0 for x, and I get my c value right there. So my y-intercept, where it crosses the y-axis, is at 0, 6. And now I want to ask myself, am I dealing with a minimum or a maximum? So I'm going to look at my a value. So since a is less than 0, since a is negative, I know that my vertex is going to be a maximum, and that's because a is negative. For my domain, it's always going to be -infinity to infinity. And then my range, since this is a opening down, so since this is opening down, it's concave down, I know that my range is going to be less than whatever that maximum value is. So I look at my vertex here. My maximum value was 8. So y has to be less than or equal to 8, because this point right here, that vertex, is -1, 8. So my outputs have to be less than that 8 value. Okay? So let's go on to what does this look like if I wanted to graph this. Well, our first step is to get our AOS, and then we find our vertex, and we figure out, is this going to open up or down? Then we find our y-intercept. Then we use symmetry, because remember, this whole parabola is symmetric around that axis of symmetry. And once we find those additional points, I want to get at least 5. That's key. Once we find 5, we just connect the dots, and we draw that parabola shape. So what's that going to look like? I've got this problem. My quadratic is y equals 1/2 x squared plus 2x minus 3. As always, I want to list what is my a value, what is my b value, what is my c value. So my first step is to find the axis of symmetry. So I've got x equals -b over 2 times a. So that denominator is a little complicated right now. We've got, if I simplify it, I got -2 on top, and then 2 times 1/2 is just 1, so x is equal to -2. So what I'm going to do is I'm going to come over here, and I'm going to plot my axis of symmetry down through -2. Now I got to figure out where is my vertex going to be on that axis of symmetry. So I got to come over here and start doing my vertex. Well, I know my x-coordinate is -2. To figure out the y-coordinate, I've got to plug that -2 in. So I'm going to plug -2 in every time I see an x. So that's going to be 1/2 times 4. And then 2 times -2, that's going to give me -4 minus 3. When I simplify all this, I'm going to get out 2 minus 4 is -2. -2 minus 3 is -5. So my vertex is going to be -2, -5. So I'm going to come over here. I'm going to actually plot that. -2, 1, 2, 3, 4, 5. Because my A value is positive, I know that this is going to be a minimum, and it's going to open up. So now I got to figure out, let me move this to the side a little bit so we can get a little bit of room. My y-intercept, I'm just going to plug in 0 for x and look at my c value, and I get out 0, -3. So 0, -3, it's going to be right there. So because this point is 2 to the right, because of symmetry, I know that 2 to the left, there's going to be another point. And now I just got to figure out what else do we want to plug in. Well, I'm going to have to multiply it by a fraction of a half. So I want to think smart about this. I'm going to plug in an even number. So we already plugged in -2. Let's plug in 2. Let's see what we get. So if I plug in 2, if I find f of 2, I'm going to do 1/2 times 2 squared plus 2 times 2 minus 3. So I'm going to get 1/2 times 4 plus 4 minus 3. That's going to be 2 plus 4 minus 3, which is equal to 3. Okay? So this coordinate point, 2, 3, is a solution, which means it's going to fall on my parabola. So let's come back up to the graph. I've got 2, 1, 2, 3. And because of symmetry, 1, 2, 3, 4, 1, 2, 3, 4. I have another parabola another point that's going to be right there. I've got 5, so I'm going to connect those dots. And so I can see that my x-intercept is going to fall in between there, but it's not nice, so I don't need to label them. And that is the graph of that quadratic. I've got my axis of symmetry, my vertex, my key points, my y-intercept. You've done everything you need to do in order to graph that quadratic. So remember, your domain doesn't matter what you plug in for x, so your domain is -infinity to infinity, and your range is anything bigger than this -5, bigger than your vertex, your y value of your vertex. All right, so that's our main 2 things for today, is getting those key characteristics and then using those to actually graph a quadratic. So I think you've got 2 you try nows. Go ahead and try those out, and I will see you when I see you. As always, be good, be safe, do well. Catch you later.